Hello student, myself Nimesh Prabhakar. Welcome to Process, Dynamic and Control lecture series. In my previous lecture, we discussed about the control scheme of the distillation column. That means in that lecture, we discussed about the composition control, that means overhead composition control, that means bottom. Then after we discussed about the bottom composition control. And then last we discussed about the both product composition control. So in that lecture we discussed about the control, that means the concentration control scheme. Now in this lecture we discuss about the controlling pressure in distillation column. That means in this lecture we discuss about the controlling of pressure in distillation column. That means that there are the number of methods that are used to control the pressure inside the distillation column. So now in this lecture we discuss about the controlling pressure in distillation column. The column overhead pressure acts as an integrator and is determined by the net accumulation of material in the vapor phase. That means we can determine the overhead pressure by the net accumulation of material in the vapor phase. Column pressure is controlled by directly changing the amount of material in the vapor phase of the overhead, or by changing the rate of concentration of the overhead, which convert low density vapor to high density liquid. So that means there are the two ways to control the pressure inside distillation column. The first one approach is by changing the amount of material in the vapor phase of the overhead. That means we can change the amount of material or the flow of the material in the overhead, then pressure is maintained. That means we can control the pressure by changing the amount of material in the overhead. And the second one method is the changing the rate of concentration of material of the overhead. That means we can control the pressure by changing the rate of concentration. So these are the two methods used to control the pressure of the distillation. That means these two concepts is used to control the pressure in the distillation column. A variety of approaches can be used to control the column pressure. So which are that variety of approach based on these two schemes? So these are the approach. First one is the vent to atmosphere. Second one is the cooling water scheme. Third one is folded condenser 1. Then after folded condenser 2. And last one is partial condenser method. So this 5 method is used to control the pressure inside the distillation column. So these 5 schemes, which are that? First one is the vent to atmosphere. Then second one is the cooling water scheme. Third one is the folded condenser 1. Then fourth one is folded condenser 2. And the last one is partial condenser. So these 5 schemes are used to control the pressure inside the distillation column. So now we discuss one by one scheme. So first one we start with the vent to atmosphere scheme. So here you can see this is the diagram of this scheme. Figure show the easiest way to control the pressure in a column operating at atmosphere atmosphere pressure. In this case, the cooling water flow stays constant and the reflux drum is vented to the atmosphere. So that means this is a very simple scheme or a very easiest scheme compared to the other scheme. And in this scheme we can see this is the condenser, that means in the round shape you can see this is the condenser, and next to the condenser you can see this is the accumulator, or we can say the reflex drum. So here the some amount of the air, or we can say there is a flow of the vapor is being vent to the atmosphere. So we can control the pressure inside the column. Thus the reflex drum can drum and hence the top of the column are at the atmospheric pressure. Now we discuss about the advantages and disadvantages of this scheme. So the advantage of this scheme is that it requires one less control valve. That means compared to the other scheme, here we require one less control valve. And now we discuss about the disadvantage of this scheme. So the disadvantage is that the top have to be subcooled so that the minimal amount of vapor is lost through the vent. Hence, more energy is required from the boiler when the reflux is added to the top of the column. So here we can see this is the disadvantage of this scheme. That means here the more energy we require from the reboiler, that is the bottom part, when the reflux is added to the top of the column. That means here this scheme is affect the efficiency of this distillation column, because when we vent the air or the vapor inside the this reflux to the air, then there is a pressure difference is created, or due to that we require more energy. Now we discuss about the second one scheme, and the name of this scheme is cooling water scheme. You can see this is the diagram of this scheme. Figure show the most common method for the controlling the pressure adjustment of the cooling water flow. So here we adjust or we control the pressure by adjusting the cooling water flow. In this case, if the cooling water flow is increased, then more vapor condenses and the vapor pressure is reduced. So, and vice versa. That means if we decrease the the cooling water flow is decreased, then the less vapor is condensed and the vapor pressure is increased. So we can control the vapor pressure by increasing or decreasing the cooling water flow. So here we use the cooling water flow to control the pressure inside this distillation column. So that's why here this scheme name is given is the cooling water scheme. Now we discuss about the third one scheme, and the name of this scheme is folded condenser 1. Here you can see the diagram of this scheme. Figure show the classic folded condenser approach. Again in this setup, as with the first example, that means in the first scheme, there is no valve on the cooling water. Instead of the valve is in the liquid line between the condenser and reflux. So here we do not use the valve, but here we use the valve in the between the condenser, that means in the round shape this is the condenser, and in the big shape you can see this is the reflux drum or the accumulator, and between that here we use one valve. If the valve is closed, then the condenser vapor liquid will build up and flood the condenser. This has the effect of reducing the heat exchange area, thus reducing the amount of vapor being condensed and hence increase the pressure. So here we can understand the working of this system. That means if valve, that means this valve is between the condenser and the accumulator is closed, then the condensed vapor, that means liquid, will build up and flood the condenser. This has the effect of reducing the heat exchange area, thus reducing the amount of vapor being condensed and hence increase the pressure. The valve can then be opened, that means in the opposite phase. If the valve is open, the liquid level will fall, increase the heat exchange area and hence decrease the pressure. So this is the working of folded condenser method or this method. Now we discuss about another method. The name of this method is folded condenser 2. See, this is the diagram of this method. Now we understand how it works. Figure show an alternative arrangement for a folded condenser. That means this is the another method of the arrangement of the folded condenser. The first thing to notice about this step is that the reflux drum and the condenser are at the same level. So here we can see or we can compare this method with the previous method. In the previous method, we see the condenser and the reflux drum. That means the condenser is above the reflux drum. But here you can see in the figure, the reflux drum and the condenser are in the parallel level. That means at the same level we can see here. The second important point is that the vapor line on which there is the control valve is very small in compared with the overhead line. So here we can see the second one comparison compared to the previous one is the vapor line on which there is the control valve, you can see in the figure, is very small in comparison with the overhead line. If the valve is open, there is a small escape of gas. That means if valve is open, then gas is escaped into the reflux drum. This space the liquid level down the drum and up in the condenser flow it and reducing the heat exchange area as in the last lecture. Therefore, to increase the pressure, the valve is open, and to decrease the pressure, the valve is closed. So here the simple funda is used. If the pressure is increased, then the valve is open. That means the air, that means vapor inside the drum is going the outside and the pressure is decreased. And if the pressure is decreased, then the valve is closed so that the pressure is maintained or increased inside the drum. So this is the method of folded condenser, of the controlling of the pressure of the distillation column. Now we discuss about the last one method, and the name of this method is partial condenser method. So here you can see this is the diagram of this method, that means partial condenser method. The final example is the control of partial condenser. The above scheme is used if the overhead product is required as a vapor. That means this scheme we can use when we require the overhead product as a vapor. That means if we require the overhead product as a solid or liquid, then we cannot use this scheme. But if our distillation product is the vapor, then we can use this partial condenser scheme. So in this lecture, we discussed about the controlling of pressure in distillation column, and for that we discussed about the 5 schemes, which are that first one is the vent to atmosphere, second one is the cooling water scheme, third one is the flooded condenser 1, then after flooded condenser 2, and last one is the partial condenser method. So in short, in this lecture we discussed about the controlling pressure inside this distillation. So as per the GTU point of view, this is the most important question and many times asked in the GTU exam, that explain the controlling of pressure inside the distillation column, or explain the which are the different schemes that used to control the pressure inside the distillation column. So this is the most important question as per the GTU point of view. So in this lecture we discuss about the control scheme of pressure inside the distillation column. Thank you.